Hey guys,
Hey, hi. Hi.
hey Tanush, how's it going? Welcome to the meeting.
Yeah, thanks. Yeah, all good. All good with you. I hope all good with you too. Yeah.
Hello.
In my
Hey
first
Tanush.
meeting, it's my first meeting in the k8gb community.
Yeah, amazing. Super happy you joined.
Yeah.
And we have Nuno around, and that's exactly the guy who will be able to chat about private DNS scenario.
Yeah, I saw both of yours presentation the last con like on YouTube. I got to know about the project from there, and then I started started tried to use it, and also I got stuck in somewhere with the private zone thing. If there's a solution, that's very nice, because yeah, some of our customers might want private zone only.
Yeah, totally. And can you share your use case for KGB in general?
Essentially, I think the basic use case of k8gb is the use case that I am interested in. So like if there is a multi-cluster environment, and there are, suppose a suppose an ingress is exposed over multiple clusters, then the route 53, or azure, in our case, it should expose only the healthy endpoints, like across the all the zones. So uh, at the moment, I was just looking at the normal round robin scenario only, but just with the private DNS. So it's, I think with the GSLB part, I also had done the setup just before this call, and it's looking good with the public zone thing. Just this one blocker is there. Yeah.
Got it. So hopefully we'll be able to sort it out today. But yeah, I think we can start with overall agenda. So I will share the link to this document in a bit in a chat. So everybody in sync. So share it in chat just in case you don't have it, and please feel free to add yourself to the attendee list. And yeah, super quick on updates that I put into the meeting, into agenda before the meeting. So Flaky tests, long-term pain. At least it was super annoying for a real while. What I did is I tracked the tests that involved parallelization, and while they were visibly like killing the test up in parallel. So sometimes it was green, sometimes it was not. So basically I disabled parallelization in the affected tests, and it became almost green with some exceptions. And yesterday night I identified this exception, and that's only one test apparently that is failing pretty good out of many. And yeah, the standard run, I can show you so the full picture. So if you go to the summary uh, of a failing job, as you can see, ton of tests, right? And we have just effectively one test that is failing. So this is higher level enclosing test, and this is start pod info again on the EU cluster, which is kind of executing failover scenario. And what I did find, this one is not related to parallelization apparently. So I got the dump of the logs, and it looks like it fails with 503. And it seems to me that it just, a race condition. So the testing pod just cannot start fully yet. And that's it. You need to tweak a test a little bit, and it should be fine. So it has like a quite like a layer of abstractions to handle. So I'll try to fix it in pretty soon and coordinate with the author of the test. Michal wrote this abstraction, so I don't want to break anything. So I will be like, carefully testing this one out. But anyway, Even with this one that is currently, it's not always failing, it's flaky, right? So we have a pretty good ratio of green runs, and it nicely unblocks us with this long-term PR. So Twitter can basically make a rebase and rerun stuff. So I expect that it will either be green, or if it will be still red, we will identify like a more deterministic what's actually happening, because now we have a pretty deterministic test run. Hey, Michal. Hey, Vitor. Hey, folks.
Hey guys.
Hey. So was just talking, Michal, about Flaky tests that are almost fixed, almost fully green, and one failing one was identified yesterday, and this one is not related to the parallelization. It is actually like a kind of cold start of the test pod with 503. So in this abstraction, in utils extensions, we might need to add some, handling of this temporary non-successful HTTP code, right? It looks like it just, it just a race condition that is hit from time to time. Yeah, so that's something like we can fix pretty soon. Otherwise, so I already showed guys, right? So overall, it looks pretty good. So from last, I don't know, 10 runs, 10 plus runs that I was executing after the fix of Flaky test with parallelization over multiple PRs, most of them green, right? So like this one is the only one that is left, like problematic state, and it fails relatively rarely. So again, in much better situation now with pipelines than before. And yeah, and with that in mind, we can look into long-term PR by Vitor. So Vitor, whenever you have time, please rebase your PR and basically try out the new state of the pipelines. They should be fixed, right? So and if it's failing, then random with one Flaky test. If it's not something that is described here, then it's most probably a real issue, some inconsistency or misconfiguration. So now we have a much better visibility, and we'll be able to figure out what is actually wrong.
Okay.
So cool. Thank you. And I plan to do 0.12 release with the Cloudflare support. Basically, I added Cloudflare support a while ago, like a couple of weeks or maybe months. Time flies. It is this PR. Yeah, last month it's all tested. It all works. We added the documentation, and documentation now has the Cloudflare support, I believe. But the thing is that it's written as documentation for a stable release, but we never did a release for that stuff before, and I totally forgot about it, and that's why we had this issue recently. Unfortunately, after already closed it. I think it shouldn't be closed. Basically, when you try out to follow this documentation, you have a failure with the schema because the Cloudflare support is not yet part of official Helm chart. So we need to release that, and I can handle it. The overall question to you folks is, do you think if we should include something into our upcoming release? Do you have open PRs or the PRs that you want to open soon and we can include it into the next release? Maybe Nuno with Azure public support, something like that.
I have that on a fork, and I was planning to do the PR with that code this week. So eventually, it's something we could look at.
Yeah, that's great. So please just let me know how it looks. So we might close the release for another week, or we can just do 2 consequent releases, nothing blocking. So let's just coordinate how the week will look like in the terms of the load, etc. So yeah, now we can go proceed with the private DNS scenario discussion.
Yeah.
Luna, stage is yours. I'll probably stop sharing.
So starting with the general description of the problem that we have. So if we are using public DNS, Azure public DNS, things work. It's just a matter of putting the right credentials in the right place, using the right configuration, and we can propagate the most troublesome record here, which is the name server record, so that the core DNS in the clusters gets called when resolution is happening. The problem with Azure Private DNS is that it does not support name server records. So we have an issue of propagating the DNS request to the right places. To address that, we must use, let's call it, an intermediate DNS server. So for instance, typically when Azure customers deploy an enterprise design, something like, for instance, a landing zone to Azure, they deploy, for instance, if it's a Windows company, so to speak, they typically deploy domain controllers, Windows domain controllers, and those domain controllers are used also for DNS resolution. Not to find VMs and so on, typical private DNS story. In that scenario, for instance, where you have the records in the Azure private DNS zones, those private DNS zones are already addressed through those DNS servers, those Windows DNS servers that resolve the rest of the queries. Because typically the Azure private DNS zone is peered to that VNet, and the domain controllers can reach out to the private DNS zone, standard landing zone, Azure landing zone design. So here for k8gb, the most simple thing, for instance, in that scenario is just to go to the Windows DNS server and add the necessary records so that k8gb instances are registered in that Windows DNS. The fact that behind the Windows DNS, we are using Azure private DNS zones is almost a detail, because the configuration is done targeting that Windows DNS server. For that to happen with k8gb, we have this PR that we were talking about, 1064 from Victor, because Windows DNS requires Kerberos authentication for you to be able to push content in, for you to be able to update records. So this PR allows us to use Kerberos authentication using the RFC 2136 pattern, and with this, we can connect to that Windows DNS. We can connect k8gb to that Windows DNS, and it just works as expected. But using the Windows DNS server pattern is just an option, because some companies, they don't have Windows DNS, they have, for instance, bind servers to do the infrastructure DNS resolution. So for bind servers, it's the same pattern, but that's already supported because k8gb has support for RFC 2136, and because bind doesn't force us to use Kerberos, we can configure it now using the RFC 2136 provider, and it works. Scenario,
that,
yeah, go
that is
ahead.
great. And we have it in a local scenario where we have a like a make local uh, deployment target, right? In a make file, like a standard stuff. We are deploying a HDNS with a bind, and it already uses RFC 2136. So you have like a local representation how you can potentially solve that, right? With a local bind.
In a scenario where, and I think I'll share my screen now. If you can stop sharing things, let
Yeah,
me
let's go ahead.
know. In a scenario where you have a deployment without Windows, typically, or eventually without bind, then we need to go through a couple of hoops more. And that's the code template that I'm finishing to push an example and the documentation in this new PR. And that's basically by using a DNS private resolver, which is specific managed resource type in Azure that takes the place of these Windows DNS servers or bind servers. But the pattern is the same, meaning that we have, let me show you an example. For instance, I have this cluster that I'm using to test, this AKS EU cluster, and this cluster is on this VNet EU, and this VNet has just one DNS server configured, this IP 10314. Actually, this IP is the IP of this DNS resolver. So this DNS resolver instance, because it is deployed in the same VNet, which I'm just calling VNet Global in the example, and it basically just has this and the Azure PrivateDNS zones, like for instance this one that I'm using for testing. This PrivateDNS zone is linked to the same VNet where we have the DNS private resolver. We end up in the same pattern of having an infrastructure piece doing DNS request forwarding to the right place, which is basically what we don't have from the native Azure PrivateDNS zone. We have this piece that has the rules to say, okay, this should go to the core DNS that's running in the cluster. And with that in place, there's only one more thing to fix or to configure for this to run, and that's credentials, meaning that so if we want to update this private DNS zone, then we need to configure credentials at the cluster level to be able to write to the zone. One thing that's not properly supported out of the box is the use of managed identities to connect to the private zone and get and update the zone. So one of the things that I'm also showing in the example is how to actually force managed identity instead of having to create and manage service principals and having the trouble of rotating secrets and all of that on a day-to-day basis, is how to use a managed identity to then connect what we've deployed in the clusters to the zone, and for those deployments to be able to update the zone. But in general, this is the pattern. We put an infrastructure piece in the middle to actually forward the request to the right places.
Yeah, that's super cool. Thank you so much, Nuna. So if I understand correctly, for the managed identity part, does it mean that external DNS controller should be able to use it, right?
Yeah.
And
So
and
the
do you
thing
know
is
if they can do it already, or?
the external DNS default deployment does not support picking up an identity from EMDS, the internal Azure endpoint that gives out managed identity tokens. So we need to actually configure the cluster to do that for external DNS when the request is coming out of external DNS.
And how this configuration is done?
It's basically configuring a workload identity for
For
external.
specific pod?
Yeah.
For specific pod, okay. And we can probably propagate it through the overall global k8gb Helm chart, right? All the configuration picks.
Yeah.
I think, yeah, cool. Yeah, that looks super promising. Tanuj, how does it look to you? Do you have any questions?
I wanted to just kind of say it out loud what I understood, like if it makes sense in a small just to make sure that we are on the same page. So essentially, by you uh, by using the DNS resolver, you want us to point our VNets DNS request directly to the core DNS port. Is it?
Because we can't use the NS records to actually propagate that to those servers. In the case of the private DNS resolver, we need to put a rule saying that if it's for this domain, then ask that guy, ask that server, you know?
Yeah, got that part, but I am not sure I got what the private DNS zone is for if we are only relying on DNS resolver along with the core DNS.
It's just to publish the service endpoint, basically. So it's still resolvable, you know?
Also, that's another way, is it like, or both are required? That's the question. So if I'm setting up the resolver, DNS resolver, you actually I'm not that familiar with the resolver itself. Is if it is resolving directly the core DNS, resolving directly to the core DNS, then if I don't set up a private DNS zone itself, should it work or should it not work?
So we've gone through three scenarios. So for instance, in the cases where we are using Windows DNS, we can actually keep that zone updated now within Windows DNS if we want to. If, for instance, we have a use case where we don't want to do that, we just want to keep forwarding information in Windows DNS and manage, because of propagation and latency and whatever, just have every server call out to Azure. So in that case, we have external DNS writing still to the private DNS zone. And the rest of the information, basically the DNS records, are there just to make sure we propagate requests to the core DNS servers, basically. But for instance, in bind, as you were saying, you can just use bind if you really want to.
So it's kind of reverse proxy for DNS, right? Yeah.
Exactly. So in that scenario that I was describing, where we're just doing we are keeping the records in the private DNS zone. The basic argument there has to do with reliability, because one thing is one VM doing stuff. Then another thing is a global service that, if I recall correctly, it's 5 nines uptime. So those work a lot better than 1 or 2 VMs staying up. And so the real info in this scenario, we keep it in the private DNS zone. Yeah.
Yeah, got it. The private DNS zone is essentially replacing the public DNS zone. Like for propagation of the state, we are still using the core DNS. Like for multi-cluster state propagation, we'll still be using core DNS, but while rendering the information, we will also create a DNS endpoint object which will directly propagate to the private zone.
Yeah.
Yeah, got that.
Anyway, I expect to have this example fully documented in the next days, in the next few days. So I think it's a good, it's a good content if you want to take a look at, and then share some comments, questions, and so on.
That would be awesome, looking forward to it. Would be great.
Yeah, so we have also Deva with us. He and I work at Tetrate. So he's my manager at Tetrate.
Hey, Deva, nice to meet you, and thanks a lot for joining.
Hey, Yuri. Yeah. So Tanuj did say a lot about you. Thanks for helping us out. It means a lot to us and the whole community as such. This is a great project, by the way.
Thank you so
had
much.
we known, we were experimenting something on our own. Tanuj knows about the details as well, but then stumbled upon this, and we saw a great fit with how we want to deliver our project with k8gb. This is awesome. Yeah.
That is great, and you're more than welcome in this community. And yeah, we're super happy to hear this feedback about the project, and that it is useful. So for private DNS part, no, I think will be super cool, like a part of like generic documentation extension, right? Some reference piece in a repo and some blog post about it later on, because it's kind of extending story, right? Like, k8gb for private. I mean, we kind of presented it on KubeCon already, but it was not in the form of a well-documented pattern, right? So that's something like to reinforce that would be super cool. Yeah, also happy to work together on that. Yeah, that is amazing. Like I like now it like formed in my head much better than before. So we can use basically any DNS, right, as a reverse proxy for that scenario, even like a standalone core DNS if you like, right, somewhere. Well, maybe yes, maybe not, because I don't know on top of my mind if core DNS supports the RFC for remote configuration, because it's minimalistic. But anyway, like some DNS servers that where we can configure NS records dynamically, right? So to create this zone delegation. But yeah, that is a very cool pattern, very extensible. Thanks a lot for preparing the material for today's presentation. I really appreciate it. Yeah, so we almost at time. Last but not least, I got a ping from CNCF out of voting in a standard maintainers survey, and basically I was a little bit grumpy in a optional field feedback and said, like, annual review is already stuck for several months, so not super quick. And yeah, they expressed the actual like situation that there are long queues, but good news for us that annual review is actually not blocking application for incubation, and we by documented thresholds we already can apply. We have 3 public adopters, we have a pretty vibrant community, we have a continuous contribution flow in the repository, so nothing stops us. So if somebody likes to work on CNCF style documents and PRs, please let me know because I find it painful myself. So Yeah, I'm looking at you, Nuno. You're great at that stuff, so I will probably ask for your help. So yeah, and I think my feeling that there is like no like a rush in that process, and there is a still long queue for incubation review style, and like early next year apply for some good polished document will be pretty good move that we can do for the project and associated visibility. That's it. Any comments? Cool. All right. So thank you so much, folks. And probably Michal, do you have anything to add to today's agenda? before we drop off?
No, very sorry. I didn't prepare. I just
Yeah,
want
no.
to send big thanks to Nuno. Good job, man. And yeah, thank you a lot.
Cool. All right. That's great, folks. And Vitor, please ping me anytime if you need any help with this PR rebase, so all the pipelines and associated test probable fixes. So I will be happy to jump into it and yeah, push this one forward. All right. Thank you so much, guys. Appreciate all your contributions, and yeah, next meeting will be probably next year, because the scheduled one is 27th. It will be more Christmas time for most of us, so most probably we will not meet in the end of the December, so I'll cancel it. So see you in January. Thank you so much. And yeah, if anything, we can always chat asynchronously in Slack. Thank you. Cheers. Bye-bye.
See you guys. Bye.
Bye.
Bye.